Hello students, so we'll see about electrical resistivity table. So this table is present in your textbook, table 12.2. I have taken some of the materials of conductors and alloys and insulators. Still some are there, you can see that in your textbook. See here, what is so we learned about electrical resistivity. This is represented by rho. So SI unit is ohm meter. You should remember these all things. See the conductors here. You have known conductors. Conductors are those who allow the electricity to pass through them. The materials which do allow the electricity to pass through them are called conductors. What see here? The conductor silver, copper, aluminum, tungsten and nickel. See their resistivity. It is 1.60 into 10 to the power minus 8 and copper 1.62 into 10 to the power minus 8, whereas aluminum is 2.63 into 10 to the power minus 8 and tungsten is 5.20 into 10 to the power minus 8, whereas nickel is 6.84 into 10 to the power minus 8. See, their resistivity is very less, of the order 10 to the power minus 8. 10 to the power minus 8 is very less. It is too much less. 10 to the power minus 8 means what? Okay, so almost one part of it is very less. Okay, 10 to the power minus 8 is order is very less. Hence, conductors have low resistivity. Low resistivity means there will be much flow of current. So they allow the flow of current because they are having very low resistivity. So one question will be asked to you in your CPS exam: why copper and aluminum are preferred more to make wires? Why almost all the wires are made up of copper and aluminum? Because copper and aluminum having very low resistivity. They can conduct the electricity in a proper way. So that is why copper and aluminum are used to make the wires and they are economical. One question you might ask: why silver is not used? Because see, silver can be used, but what happens is the economic way of looking at the silver is difficult. It is little bit what precious, means it is little bit having more. It is not economical, it is not cheap. Okay, these two are cheap compared to silver. Silver is having more money, means what? If you use silver for making wires, we should spend lots of money, and economically it is not durable. Economically it is difficult to maintain. So that is why copper and aluminum are used, because they have the proper resistivity, that is low resistivity for conducting electric current, and they are economical also. Hence, copper and aluminum are used to make wires. Why copper and aluminum are used to make wires? Because they have low resistivity of the order 10 to the power minus 8. Okay, and they are economical also. Hence, they are used to make the wires. Second, here we comes alloys. I have taken two alloys here. One is manganese and the other is nichrome. Manganese is the alloy of copper, manganese and nickel. Copper, manganese and nickel. Cu means copper, Mn means manganese and Ni means nickel. So all these three include to form an alloy manganese. This alloy is the resistivity of the order 44 into 10 to the power minus 6. See here the resistivity is little bit increased. Here the resistivity is less, 10 to the power minus 8 is less, 10 to the power minus 6 is more. When minus 6 comes, it is more. Don't think that 6 is more than 8. Here it is minus symbol. Minus symbol in the sense 44 into 10 to the power minus 6 is more compared to 10 to the power minus 8. So the resistivity of manganese is more of conductor, means alloy's resistivity more compared to conductor. So hence there is not much flow of current. Okay, they can conduct little bit if some conditions are improved, means some temperature is given or some other external conditions are improved, there is a chance of conduction. And nichrome also can be used for conduction. Okay, but nichrome wire, look here, it is an alloy of nickel, chromium, manganese and Fe. Nickel is a metal, chromium is a metal, manganese is a metal, iron is a metal, all including nichrome is a wire. It is an alloy. Nichrome is used for conduction and its resistivity is 100 into 10 to the power minus 6. That means it is very, very medium. It is little bit more compared to conductors. So, this is not too much resistivity. This is medium resistivity. Hence, to certain level, it can conduct the electricity. So, sometimes even nichrome wires are also used to conduct the electricity. And lastly, we come across insulators. Insulators are the materials which do not allow the electricity to pass through them because they have highest resistivity. For example, glass and paper. See, the resistivity of glass is of order 10 to the power 10 to 10 to the power 14. It is highest order. This is plus 10 to the power 10. This is in the order of plus. Power is plus 10 and plus 14. Their minus power was very much less. This was too much high. And paper, that is dry paper, we have to take. That is 10 to the power 12. This is also too much high. Hence, the resistivity is too much high means they do not allow the electricity to pass through them. Resistivity is opposition. If the opposition is too much high, then current will not pass. So, insulators will not allow the electric current to pass through them, electricity to pass through them. Hence, these are bad conductors of electricity because they have high resistivity. Remember this. Conductors are having low resistivity, very low resistivity, whereas alloys are having low or medium resistivity, whereas insulators are having high level of resistivity. And question will be asked on copper and aluminum. Why copper and aluminum are used compared in making the wires? Because copper and aluminum are having very low resistivity and they are economical also. Hence, copper and aluminum are used to make the most of wires. This is regarding insulators, conductors and alloys. After this, we will move to the problems. And there are still other alloys and metals are there. You have to go to table 12.2 in your text. See, we'll go to problems now. We'll make 2 or 3 problems today. So, before going to problems, we learned, see, up to Ohm's law, one problem concept we will done. And after this, we'll have other theory concepts also. Those are resistors in series, resistors in parallel, heating effect of electric current, power. So we'll have those also. That's a different set of problems. After finishing this chapter, we'll have those set of problems. So first we'll have these set of problems. The problems, we have 3 formulas up to Ohm's law. We learned about formulae. What are those 3 formulae? You should have these. You should be perfect on these. We have learned about 3 formulae. What are those? First one we learned Q is equal to I by T. So we can write Q is equal, I is equal to Q by T. So we can write Q is equal to IT also. Second formula is voltage V equal to work done to the charge W by Q. Third formula we learned, that is Ohm's law, V is equal to IR. These 3 formula we should remember. I by Q, W by Q and V equal to IR. These are the 3 formulas. I means current, ampere SI unit, Q charge, T time, SI unit second, here coulomb. Voltage or potential difference, SI unit volt or measured in volt. Work done, SI unit is joule, work done is energy. Q charge again, SI unit coulomb. Again voltage, SI unit volt. I cent ampere, that is I means current, R means resistance, SI means O. So we learn about the problems. Okay, let me start with the first problem. Okay, I am going to start with the first problem. See the first problem here. Calculate the amount of work. Calculate the amount of work. Calculate the amount of work if 10 volt cell. If 10 volt cell passes a current of 10 ampere. Passes a current of 10 ampere in 10 seconds. This is our problem. Okay, so we'll do this problem. Look here. Calculate the amount of work if 10 volt cell passes a current of 10 ampere in 10 seconds. So while solving the problem, first thing you have to do is we have to write what is given. While reading the question only we have to write. See then, calculate the amount of work. They have asked work. So give the question mark for work. Okay, they have asked work. If 10 volt cell, see they have given V here, 10 volt. 10 volt means it is voltage, potential difference. Okay, that is V equal to 10 volt. Passes a current of 10 ampere in 10 seconds. Then they have given 10 ampere, that is current. I equal to 10 ampere and time t they have given 10 seconds. Just we need to find out W. So what is the formula here for us? W is this formula, right? V equal to W by Q. So I will write V equal to W by Q. But what I want W, right? So I want W means if this will come this side, W equal to V into Q. Do you agree? Okay, but Q is not there, but Q is equal to I know I into T. Here I is equal to Q by T, only Q if I want it will become I into T. So I will write W equal to V into, in place of Q I will write I into T. Do you agree? Q, look at formula here, I is equal to Q by T. So I want only Q. T will go this side, Q equal to IT will become, so in place of Q I will write IT, VIT. So W is equal to, what is our V? 10 volt, I 10 ampere, T 10 second. 10 means 10 into 10, 100 into 10, 1000. So W is equal to 1000 joules. So this much work we have to done. The amount of work done is, or the amount of work is 1000 joules. So this is the way. So first what you have to do? You have to remember all these three formulas, and on what basis what is given you have to write first. On that basis you have to choose the formula. What are the quantities given to us? On that basis choose the formula. Here VIT is given, W is asked. So W is equal to VQ is the formula must be used. V is equal to W by Q. If I take Q this side, W becomes W equal to VQ. So that formula is used, but Q is not there. So for that Q equal to IT, that formula should be used. So in place of Q write IT, W equal to V into IT, it will get 1000 joules. So pause the video, note it down. We'll move to the second question. I will write down the second question. See the second question. A current of 5 ampere, a current of 0.5 ampere is drawn by filament of an electric bulb, filament of an electric bulb for 10 minutes. For 10 minutes. For 10 minutes. Find the amount of electric charge flows through the circuit. Find, this is in your text. Find the amount of electric charge flows through it. Okay. See, understand now. A current of 0.5 ampere is drawn. So what is given? Understand properly. Given. What is given here? Current of 0.5 ampere. So I is given. That is 0.5 ampere. Current is I. Ampere in the sense it's SI unit. So it is given in ampere, means it's electric current. Is drawn by filament of an electric bulb for 10 minutes. Time is given as 10 minutes. But minute is not my SI unit for time. The SI unit of time is seconds. So whenever anything is given, that time is given in minutes, you must convert it into seconds. 10 minutes means what? 1 minute means 60 seconds. So 10 minutes means what? 10 into 60. That is 600 seconds. Next they have asked the filament of an electric bulb for 10 minutes. Find the amount of electric charge flows through it. I need to find out electric charge. See, in one wire, a 0.5 ampere current is moving. That is, electric bulb is drawing that 0.5 ampere of current, and it is for 10 minutes. I need to find out what are the amount of charges flowing in that circuit. Okay, what is Q formula? We know that I is equal to Q by T. So what is Q formula? Comes this side, Q is equal to I into T, RIT. I they have given 0.5, T they have given 600. 0.5 into 600. 0.5 is half. If you half the 600, 300. Half of 600 is how much? 300. 300. Q means it is coulombs. Q is equal to 300 coulombs. So this is the way you have to remember. First you have to write down what is given and what data is given. On that basis choose the formula, and after solve the problem, and don't forget to write the SI unit at the end. This SI unit is compulsory, otherwise you will lose the marks. Okay, so this is regarding second problem. So we'll move to the third problem. If you have any doubts, so please pause the video and write down again and understand it. Okay, and we'll move to the next third question. We'll move to the third question. Third question is like this. How much current will an electric bulb draw? Will an electric bulb draw? This is a little big question. Electric bulb. Will an electric bulb draw from a 220 volt source? From a 220 volt source. If the resistance of two bulb, the resistance of the bulb filament is, the resistance of bulb filament is 1200 ohm. 1200 ohm. How much current will an electric heater? How much current will an electric heater How much current will an electric heater coil draw from a 220 volt source? Coil draw from a 220 volt source. From a 220 volt source, if the resistance of the heater coil is 100, if the resistance of the heater coil is 100, resistance of the heater coil is 100, heater coil is 100 ohm. Okay. Now we'll look at the question and understand it. I think it has taken lots of space, but still it's okay. Okay, we'll look at the question here. Understand? How much current will an electric bulb draw from a 220 volt source? They have given source as 220 volt. Okay.